Our agenda for today is to offer a brief introduction to landslides in our region and their impacts on streams and roadways. We are going to have our speakers talk about some ways to mitigate and repair slide impacted areas. We have Kevin, who will discuss a recent project completed in Lincoln Borough that addressed drainage and slide repair with using DGLVR funds. And we also have Scott, who's worked with the dirt, gravel, and low volume program before, and whose company uses specialized techniques to rebuild walls and slide impacted areas. A special thank you to the Pennsylvania Association of Conservation Districts for their support of this webinar through their non-point source pollution mini grant. And without further ado, we are going to get started. So, as a reminder, this is just an introduction to this topic. And so there's going to be a lot of material that's covered. And if you feel like you need some more information following the webinar, I am happy to send out additional resources. Landslides in Allegheny County are very common, and this is due to some of its unique geologic and topographic features. The history of landslides in Allegheny County are pretty well documented, and they stem all the way back to the settlement of this region by Native Americans. In fact, the Native American translation of Monongahela River is river with sliding sides. In more recent history, we can look to emergency service files that date back to 1975 that also show similar landslide and flooding issues. A 2001 PA geologic survey published by the Department of Conservation and Natural Resources listed landslides as a very significant geologic hazard through most of Southwest PA and also in certain other parts of the state. I'm sure many folks joining us today would be able to share about a landslide they know that has impacted their community. The majority of photos from this presentation are landslides that I've personally seen in my travels around our county. So I can even share firsthand experience about how much we see regularly this issue. And just to put a couple numbers to the topic, in 2019, there were 123 active landslides reported in Allegheny, Beaver, and Lawrence counties. An additional 250 slides were reported in Washington, Fayette, Greene, and Westmoreland counties. So that's 373 landslides and doesn't even encompass all of Western PA. So it's obvious that this is a pretty big topic. Next slide. To be specific, today when we're talking about landslides, we're looking at this definition you see on your screen. A landslide is a downslope of movement of rock, soil, or both, in which much of the material often moves as a coherent or semi-coherent mass with little internal deformation. Now, if simply put, a landslide is the movement of unstable rock, unconsolidated earth, or debris moving down a slope. And if you're listening to this definition and thinking it sounds like there's a lot of variation in slides, you're absolutely correct. There are different types of slides that are categorized by type of movement. And the main types of movement are falling, sliding, and flowing, but combinations are also common. And material can move in nearly intact blocks or be greatly deformed and rearranged. The slope itself also plays a role, whether it's nearly vertical or fairly gentle. There are 4 main types of slides, and I'm going to go through these pretty quickly. Keep in mind, again, this is an introduction, so there's a lot more information that we could go over about slides, but we're just going to keep it short for today. The first type of slide here is what we call a translational slide. And this type of slide is when the mass moves out or down and out along a relatively flat surface with little rotational movement or backwards tilting. These types of slides are pretty common along geologic discontinuities like faults, joints, bedding surfaces, or the contact between rock and soil. And in the north, we also see them along permafrost layers. They're typically triggered by intense rainfall and rainfall that causes a rise in groundwater. This rise in groundwater could also be caused by snowmelt or flooding. And they can also be triggered by human uses of water like irrigation. Human-caused disturbances like undercutting can also cause this type of slide. The second type is a slow earth flow slide, which is also called a creep slide. And these get their name from this imperceptibly slow, steady downward movement of slope-forming soil or rock. There are three types. There's a seasonal creep, which is caused by seasonal changes in soil moisture and temperature. There's continuous, where shear stress continuously exceeds the strength of the material. And then progressive, where the slopes are reaching the point of failure for other types of mass movements. And again, seasonal creeps are also triggered by rainfall or snowmelt, but also chemical or physical weathering, leaking pipes, poor drainage, and destabilizing types of construction. The last two are similar in that they use a lot more gravity. So rockfall slides are abrupt movements of rocks that detach from slopes, and these are caused by natural undercutting, so stream bank erosion or construction activities, differential weathering, and other human activities. And the last type of slide is a topple slide, and this is the forward rotation on a slope of the mass of rock around a particular pivot point. And this slide, gravity or water and ice in the mass itself leads to slope failure. That is a lot of information to absorb, but if you were paying attention, you may have noticed that there was a bit of a theme when it comes to the causes of slides. Even though the slides may have different methods, they're all caused by a set of key principles. And knowing the principles of what causes a slide can help to choose your point of attack when you're going to be preparing or mitigating the effects. Some things we can't change, like topography and slope steepness, but other factors we can keep a better eye on. I'm going to talk a little bit more about soil specifically. That is really the starting point for slides. Overly saturated soils can be prone to slides because water makes the soil become buoyant, and water can weaken pre-existing weakness in the soil as well as weakness derived from human intervention on the landscape. Saturation is this key factor. This makes soils more susceptible to shifting. And in the Pittsburgh region, we have a lot of clay-rich soils and weathered rocks, and these soils become waterlogged and then cause a lot of shifting. We also have what's called the Pittsburgh red beds, and these soils are a layer of claystone rock that deteriorates when exposed to water. And when deteriorated, again, this layer can act like a lubricated plane and all of the material slides. Which leads me to talk about water, and water is the key here. So if soil saturation is the cause of the landslide, finding the cause of the soil saturation is key. And there are a lot of ways that soil can become saturated. Number one on the list, precipitation. So heavy rainfall and flooding creates conditions that allow soil to become saturated. But we also have things in this area and other areas of Pennsylvania, like underground springs. There's a lot of mine drainage or leaking utility lines. So identifying those causes can be very important. There's also a lot of problems caused through human engineering, or engineering in a way that eliminates one problem but causes another. So roof downspouts, they can cause point discharge and lead to excessive erosion on hillsides that end up destabilizing the slope. Sometimes we install stormwater systems that are not as well maintained. And when they're not maintained, this can cause the systems to become clogged with leaf debris or other sediment, and then they're not functioning and causing erosion in other locations. Also, the use of non-engineered fill isn't as stable and can lead to slope failure. The built environment has the ability to mitigate or exacerbate landslide conditions. Some things we can change and some things we cannot change. Historically, the location of roads hasn't always been the best, but we got to work with what we've got. Road location and geography are factors that can contribute to susceptibility to slides, as well as certain construction practices like undercutting and excessive vibration can exacerbate slide conditions. But also slides can be harmful to humans. They lead to road closures and can create pretty dangerous driving conditions. Not only do slides negatively impact humans, but they're also a source of non-point source pollution for the environment. They can negatively impact aquatic environments through releasing sediment into streams and waterways in the form of non-point source pollution. Pennsylvania is ranked second in the US for number of stream miles, so that gives a lot of opportunities to protect waterways, but also can cause instances of pollution. It's estimated in the US that there are 4 billion tons of sediment deposited into ponds, rivers, and lakes annually, and 70% of erosion that ends up in streams is caused by human activity. So finding ways that we can address sources of this non-point source pollution, like slide mitigation, is pretty important. If there are any questions at this time related to this introduction, I'm happy to take those. And if not, we can move on to our next section of the presentation. All right, thank you very much. And I'm going to turn this over to Kevin.
Thank you, Riley. So I had a very sobering realization a few years ago that the entire job of a civil engineer is to basically delay Mother Nature from inevitably winning. And that could be in the form of root intrusions into sanitary sewers, corrosion of old corrugated metal storm sewer pipes, corrosion of water lines that cause significant water breaks and water loss throughout our region, roadways that need to be rebuilt and repaved after years of freeze-thaw cycle, and of course, today's topic, landslides. So what I'd like to show you as a case study is Fuhr Road in Lincoln Borough. And it's important to remember one thing about Fuhr Road is that while there's not a lot of homes on it, probably fewer than 20, 25 homes between this and Spring Avenue, it's the only way in and out of this neighborhood. So there's no possibility, if this road were to fail or to become impassable, there's no way for these residents to get out. So in October of 2019, Fury became restricted to one lane for a certain run of its length because of the erosion of the hillside that started to compromise its integrity. And just purely out of caution, as a couple feet of it were already lost. And if you can kind of squint, you could see the Jersey barricades there and the guide rail behind it. They made the decision to close it and restrict it to one lane. Part of the majority of the reason for the erosion is that there's no stormwater controls on the road. It's one of these roads that started off as a small farm road and then put down some gravel, and then every once in a while they had some extra asphalt, and then all of a sudden now it's a full-blown road. But it was a very narrow road that was perched on the side of a hillside, and there was no stormwater controls to speak of. So water would come down from the top of Fuhr and then be diverted over the hill near the intersection of Spring Avenue and Fuhr, and that would start to eat away at the toe of the slope of what was already an unstable hillside that was used over the years as a dump site. So KLH saw this as a two-part project. Phase one is that we had to control the stormwater issues. This is a picture looking from about halfway down what we call the top half of Fuhr. And you can see the eroded out channel off the edge of the road there going behind the group of mailboxes. So we had to first control that runoff and then start to slow down the effects of the erosion of the toe. The second part was that we were going to relocate the road 10 feet over away from the currently eroded hillside. Lincoln received funding from three separate sources. First is Riley's low volume dirt and gravel program. The second was from the CITF fund, colloquially known as the gambling grant, through Allegheny County. And those are funds that are generated through the revenues at the region's casinos. And then the third is the multimodal grant through DCED. And without those three sources of funding, due to the scope of this project, Lincoln Borough would not have been able to complete this without those grant funding sources. So we're very appreciative to all those entities. In February of 2020, work began on phase one to control the stormwater. So a contractor was brought in to create a new storm sewer system that collected the water primarily from the upper part of Fuhr. At the intersection of Fuhr and Spring, you can see the series of inlets here to catch that water. And behind the mailboxes, if you can see in that picture, there's a gravel infiltration trench that we put in as well to gather some of the groundwater that was coming out of the folks' yards there and getting onto the road. So behind that orange and white barricade in the dirt area, it's probably not very visible, but there's a stormwater manhole. So the water was conveyed into that stormwater manhole and then taken over the hill to a second stormwater manhole in order to control the slope grade of the pipe. From that second stormwater manhole, it exited at just a 1% slope into a riprap channel that was able to control the velocities and minimize the effects of erosion on the toe. I should also point out that as part of their MS4 program, Lincoln Borough has a TMDL for sedimentation. So as Riley alluded to in her part of the slide, this project also helped them on their MS4 program control sedimentation into this unnamed tributary to Wiley Run. So the second phase, once the stormwater was in, the second phase was completed in earnest. And there were three alternatives that were considered. The first was a pretty standard retaining wall type of design, but because of the unstable soils in the hill, we would have had to have gone down 30 to 40 feet to the bottom of the hillside and build the wall up. And and get it onto stable ground. That would have been a very expensive proposition. The second option that was considered was to install gabion mattresses under the existing road, but we felt that that would have minimized and kind of hampered any future utilities that would have gone through there in order to have to penetrate through that gabion mattress. So the third option was the one that we selected, and that was to relocate the road entirely. This picture here is looking up the hill, and as you can see, the existing road was probably only about 16 feet wide. So it's a very narrow road to begin with, only 8-foot travel lanes. So what we proposed to do was to turn the current downhill, the current downhill lane, and then shift it over 10 feet into the grass on the right to create a new uphill lane. And then that was, we were able to do that with relative ease just because of the existing right-of-ways that Lincoln Borough possessed. They didn't have to acquire any additional right-of-ways. So that was the option that was done so we could get into stable ground and not have to worry about rebuilding on top of an already eroded hillside. Work on phase 2 started in August of 2020, but ahead of time, we also had to coordinate with other utilities. When you're relocating a road, you're going to be impacting the telephone poles and the electric lines. So Penn Power came in and did their work ahead of the contractor. And then PA American saw the opportunity to replace an old transite line, which is a water line that's lined with asbestos material. And they took that opportunity to replace that old outdated line with a new ductile iron main. So you can see in this picture here where that white truck is, that's where the contractor was doing his excavation to create the new slot for the new lane of traffic on Fure Road. And that went from the intersection of Fure and Spring all the way down to the end of that bend. And it was about a 700-foot relocation. Now, once you got around the bend on Fure from the previous picture, there was also a second area that was starting to slump. It wasn't a full-blown slide where the borough had to close or restrict traffic on Fure, but it was still something that was going to eventually become a problem. So as part of this project as well, we did a full width excavation that was 4 feet deep on the road for about 50 to 75 feet. Took out all the material and replaced it with a stable base of number 4 stone that was choked in with 2B gravel. This eliminated all the unstable soils and clays that were in the road and then provided a very solid road base for us to then rebuild and repave Fure Road. And in this lower part as well, storm sewers were installed, and then that stormwater was conveyed down the hill to Lovedale Road, where there was a pre-existing PennDOT storm sewer system. Work was completed in October of 2020 on Fure, so the project just took a shade over 2 months. And at the end of the project, the road was repaved from end to end, and new bituminous wedge curves were put on the road in order to safely convey the stormwater into the new storm sewer system, and to also prevent it from going over the hill and eroding out the hillside and the toe of the slope. This is a before and after of Fure Road, standing at the intersection of Spring Avenue. So as I mentioned, we put in 2 10-foot wide travel lanes along Fure Road in order to give a little bit more width to the road. We improved some areas of poor horizontal geometry, some areas of sight distance concerns going around that bend. A new storm sewer system was put in. Third-party utilities upgraded their systems as well. The road was repaved and new guide rail was installed along the full length of the road. The entire project is about 1,400 feet long, and it's a brand new road that's going to last and serve Lincoln Borough for many years to come. So I'd be happy to take any questions that anybody might have in the chat.
Thanks, Kevin. I'm not seeing any questions right now. Don't forget, if you have any questions during any of the presentations, just type them into the chat and we'll be happy to answer them. I think now we can move on to our presentation from Scott.
All right, thank you very much for the introduction. Is everybody seeing the screen okay? All
Yep,
right.
everything looks good.
Perfect. Thank you very much for having me. My name is Scott Romine. I'm the regional manager for Tensar. I cover all of Pennsylvania. So if you guys are all conservation districts, I'm your point of contact. As a manufacturer, we work in several different realms within the industry. One is to educate, more or less, to go into different facilities, different offices, educate the marketplace on product solutions, whether that is our products or somebody else's. We also go into geotechnical offices and civil engineering offices and give presentations there, as well as the state. We do work directly with the Dirt and Gravel Roads program in State College. We work with PennDOT and municipalities so that we can help them find solutions that not only make sense for their local areas, but make sense for their bank accounts as well. A lot of times by doing that, we're providing very specific value. And I say specific value because we may be looking for something that can be done quickly, can be done accurately, you know, something that can be done within a certain budget. So we're really looking for what those values are to your agencies, the contractors, and your local participants to make sure that we're getting you guys a solution that really works well. Within Tensar's scope of work, we do work under unpaved applications, unpaved working platforms, as well as foundations. We also do paved structures like parking lots and state and local roads. We have applications for under roadways, bridge abutments, and MSE structures like that you would find in approach slabs, as well as what we're talking about here, which is really slides and how they affect roads. So I'm going to go ahead and just concentrate on our GRS solutions here today during this part of the presentation. And we're going to go specifically into how that can affect how you would look at a project. What we really look for from a conservation district or a first phone call is really a little bit of information from you guys to see what soils information they have, what local hydraulic conditions you may have. Riley talked about earlier, whether that's a spring, whether you have something seeping out of the rock face of above that particular slide, whether that's a stream, seasonally high water table, things like that. And as well as any kind of E&S concerns that you may have from your local application. And really, what are the future performance needs that you need out of this? Is this a 5-10-year solution like we hear from a lot of short-term projects? Or is this something that you guys want a 100-year design on? Because that will affect kind of what solutions we can offer you guys. If you think about a GRS solution, a geosynthetic reinforced soil slope wall, however we may define that, people will say that seems pretty odd. How are we doing that, and how long has that been around? And here's a really great example of an MSE structure out in in Egypt. And it's over 3,000 years old. And this is simply reed mats that they used the exact same process that we did. And they knew that if they could confine that soil to separate lifts and get it to stabilize, that those structures could go much, much longer. So we have a monolithic structure here that's over 3,000 years old with simply reed mats. We're doing the same exact thing today, but we're doing it with geosynthetic materials because they're non-biodegradable, they last longer, and they have a better use and better performance on your projects. You guys may be used to dealing with some geosynthetic products as it refers to E&S structures or typical details. Here's a really good example of several geosynthetics that you guys will see in the marketplace. We have geocells, which is very much like an accordion type of structure that you pull apart. Those geocells are very much like GeoGrid, but much taller, and they are fully confining and engineered fill. We have woven and non-woven geotextiles. Geotextiles work in harmony with GeoGrids and can work very well with them. We also have biaxial, triaxial, and interax geogrids that are usually for base reinforcement as you are looking for a higher loading value from the top down. And what we're talking about here in today's presentation, that bottom center picture, is uniaxial geogrids, something that is going to be in tension or stressed as in a pulling direction during its life expectancy. All the way on the right is something called road drain that helps in some of your hydraulic conditions. It's a geosynthetic product that has inherent openness in its structure, so it'll allow water to go through it. What we really deal with here in our MSC structures are biaxial geogrids, uniaxial geogrids, and some geosynthetics. A lot of what we're talking about in the slides are slopes and defining those slopes, right? So geosynthetic reinforced soil slope is anything from 26 degrees up to 70 degrees. And depending on your site conditions, we can deal with that several different ways. Flatter than 26 degrees, slides don't become necessarily as big a problem or don't need as engineered a solution and are dealt with slightly differently. Once you get past that 70 degrees, you get into a wall condition. 70 to 90 degrees is considered a wall. Steepened slopes that exceed 45 degrees need further securing along the slope face. And I can describe that a little bit here in a slide to come. Some of the photos that we showed earlier depicted a slope failure with an over excavation. Riley described that earlier as well. We're pulling that failure back and we're over excavating so that we get back to some sort of good foundation or base layer. We're then refilling that up with engineered fill lifts in primary and secondary geogrids. The primary one is tied all the way back. It's typically 0.8 to 1 times the height of your slope. And then we have secondary reinforced lifts. We're going here in about 6-inch lifts, engineered filled lifts, until we get back to another primary reinforced lift. It's a very, very easy process for a contractor to do, whether it's a local contractor or a state contract that we have. It is considered, I consider it to be like a Lego solution because these are bits and parts that these guys can bring them in and just continue to build one on top of the other. You repeat that process until you get back to your goal at the top of that slope. The primary geogrid reinforcement is stretching back into that slope face and going past your global point of global stability to really tie in and connect and stop that slope failure from happening again. Your secondary reinforcements are much smaller, much shorter, only 2 to 4 feet back into that face, and they're helping the face from slipping off as they go down. We can do this with grass slopes. We can do it with roads. Once we get past that 70 degrees, we usually run into problems with constructability. That's when we start to get into different facing options. Above 70 degrees, it's much easier for a contractor to push all of that material up to some sort of constructible face. And in this particular case, we're talking about welded wire forms. It doesn't necessarily have to look like that, but we can use that as a construction aid. In this case, we are showing some guardrail here. I know that happens all over the place where these slides happen. Several photos depict the guardrail starting to tip over, a really good indication that we're starting to have some failures. Because we are using polyethylene geogrid here, you can simply punch those directly through the grid without any kind of problem. Here's a really good example of a face that goes into a stream or a pond or something that is water facing. We can also do this and change your integral design to have chimney vents along the backside of this. This is very similar to other slides that I've been to where we have some sort of exposed stacked stone wall that has come down into a slide. Most of the time, because stormwater hasn't been addressed, right? Beat that horse here. But we can go ahead and put in open grade stone so that that's water can relieve itself down into your channel, come down through and right outside, out to the wall face in a non-point source discharge. Here is a really good project that we worked on. Some of you guys may have been in this or on this project. Spicer Road in Warren County. I saw Terry logged on. I think he's up front and center there on the right. We had the ability to get you guys out on site and show you exactly what this means. Because of the height of this wall, this particular project only took up about 1 lane of this road. However, this could take up more or less depending on your particular site requirements. This one will have a vegetated face. You see here at the bottom where we actually have a rock face at the first stone core or first lift. That may be due to 100-year floodplain elevations or certain hydraulic conditions that we need. However, from there up, we have a topsoil backfill with a matted back that you can basically hydro seed, plant, and get a very native looking result. It would not look like this wire basket in years to come. So solutions like this are quite quick and easy, and they use flexible materials, things that you have on site. We can basically get your soils material and engineer around those. Gives you ability to have variable facing types, angles, as well as different sections like you'll see here in a minute where you have slope, wall, slope, maybe even access roads along that. Here's a nice little picture here of our components that we're looking at. And when I said it was a Lego system, it's because we're just grabbing Lego pieces and building this until we fill up that section. We're basically looking at some sort of reinforced wire form for the contractor to fill to, reinforced turf mat or stone behind that if you're looking for that, as well as the geogrid that would go in behind that. A unique thing about Tensar and what a lot of people like about it is that there is a mechanical connection between your reinforcement geogrid and your wire facing basket. This is a requirement for the Virginia DOT. You can't put in any kind of wall like this unless it has a mechanical face. This may look like a wall to some, but if you actually look at the overall angle, you're under 70 degrees there, so you're still considered to be a slope. Again, depending on your aesthetic needs, temporary, permanent, we have different options for you. On your left here, you see a very nicely planted vegetated face along a pedestrian path. To the right is right across from New York City in Jersey, where that entire thing is a planted slope. This is a slide in California. You can see how extensive this gets. Now, because of the depth and because of the availability of undercut there, they ended up going with a wall solution, but that again would be a hydro-seeded mat that they could basically water and have plants come back in. We've even had something as intricate as stacked stone required, where we can basically back butter those facade stones and put them directly in contact with your wire basket and get a beautification factor. These are a good representation of something that's used in harmony with a very high surcharge or a residential structure right above it and water below it. So long as we understand what we're working with at the toe of the slope and at the top of the slope, we can engineer that appropriately. This is all free services that Tensar offers to you guys, as well as your engineering staff, that we would ultimately request to be the engineer of record and review our designs. This one is actually a retention basin that we can properly engineer to accept that water as it comes in and out. Here's a good example of wire baskets used for bridge abutments, things like that, as well as some large turns around a DOT road. You can see where we went from a vertical stone face to a planted slope up to a vertical face again. This again would be a very unique aesthetic requirement, but they could have long creeping plants like you see here, or something very lush that would overcome the initial basket design. How heavy can we go above and below? This is a Lowe's storage facility directly above this wall. Some temporary applications here where they're actually using zip ties for man rails and things like that. The temporary wall construction is quick and easy, but you're not going to get the life expectancy out of that. You're going to get something around 10 years, depending on what material we can provide you. When you go to a permanent structure, all of our materials are tested out to 75 and 100 years. So you have a pretty good level of surety in that design. The grid itself is a chemically inert substance. So we use it in landfills all the time because it does not degrade over time with any kind of native situation. The last thing that I'll leave you with is really why we got started with the Dirt and Gravel Roads program to begin with. This is again on Spicer Road, where we look at the road coming in to that slide scenario. As the earth is moving, that road is moving too, right? Kevin had a very good anecdote there where we get a farm road or a tar and gravel road, and then that becomes a real road all of a sudden. And next thing you know, residential traffic turns into local traffic, oil and gas traffic, which turns into UPS and Amazon traffic. So we really want to make sure that we're armoring these low volume roads and building them cost effectively. We work with Dirt and Gravel Road program to put in a engineered structural section underneath that road, simply by adding a geogrid underneath your stone section in a top course here or a road section. You can usually strengthen your road 3 to 6 times, and your bang for your buck on that project goes very, very far. I'm happy to be here and have seen some of you guys before. I want you to know that Tensar would like to be a business partner with you guys. We don't see ourselves as a manufacturer or a sales company. We see ourselves as a key partner in the development of the US and a partner with you guys from the beginning to the end of the project. Whether that is simply coming out to the job site and making initial assessments, like I recently did in Greene County, or coming out and doing some soils testing, giving you some design criterias, or doing presentations like this, please call me up. Reach out as you guys see fit to use Tensar's free services to your advantage. I work directly with you guys as you see fit, and I'm happy to do what I can for you when I can. If there's any questions, I'd be happy to answer them at this point.
Thanks so much, Scott. If there are any questions for Scott or about the Tensar product or anything in this presentation, feel free to add those to the chat now. I'm not seeing anything coming in, but if you think of something while we do our last little bit to wrap up, make sure you get that in the chat so we can be sure to answer your questions while we have everyone here. We have a question that just came in for you, Scott. They want to know, when you say that he works with you guys, who are you guys?
Everyone on this call. It doesn't really matter. Like I said before, I work with the Penn State and I work with the powers that be there. I work directly with the DOT. I work with contractors, geotech, civils. I work with the conservation districts. Whoever calls me and is requesting services, that's where I go and that's what I do. So there's no rules or regulations on how I can engage with the industry. That's up to you guys to request it and put me to work.
All right, thanks so much. I am going to jump in here just at the end to share with you all a little bit about the Dirt, Gravel, and Low Volume Roads program. and how folks can use this program to get funding to repair their slide projects in different municipalities. So I am the point of contact for the dirt, gravel, and low volume road program in Allegheny County, but this is a program that's in 66 of Pennsylvania's 67 counties. So each county has their own program manager. The dirt, gravel, and low volume road program provides funding to municipalities to improve roads that are negatively impacting streams of the Commonwealth. We are first and foremost an environmental program with the benefit for all of you that we do work on roads. This funding comes from the state transportation bill, which allocates $28 million to the 66 different counties that are in the program. And projects can occur on any dirt and gravel road where there are negative impacts on stormwater systems or streams, or on paved roads, as long as they meet the low volume requirement and that the project will have an environmental benefit. So a low volume road, just to make sure everyone knows, that is a paved road with 500 cars per day or fewer on a typical business day. So a Tuesday, Wednesday, or Thursday during rush hour. The program itself hinges on the concept of environmentally sensitive maintenance practices. And these are practices which focus on low-cost alternatives to road maintenance that work in congruence with the natural and built environments. And it's also a certification that we require all applicants to have participated in. It's a course offered through Penn State Center for Dirt and Gravel Road Studies. And at least one member of a municipality must have attended the training in order to be eligible for funding. Right now, Penn State is offering remote ESM training opportunities. These are the upcoming dates. And if you're interested in attending one of these upcoming virtual trainings, please reach out to me and I'm happy to set you up with the registration information. It's 2 days, 4 hours each day, offered through Zoom. There are all kinds of projects that are eligible for this funding. First and foremost, determining your road surfacing, determining an environmental impact, and then we discuss what kinds of projects you'd like to do. So we do drainage projects like cross pipes, under drains, French mattresses. We'll do stream work projects with bank stabilization or stream crossings. And we also do road stabilization. So full depth reclamation, landslide repair and remediation, and so much more. There are so many possibilities. I couldn't possibly put them all on one slide. Allegheny County Conservation District, our funding cycle, we begin accepting applications every year on July 1st, and our cycle closes on August 31st. We get our funding in July. Typically, we have about $100,000 for our dirt and gravel projects, and plus or minus $270,000 to fund low volume road projects. To date, we've assisted 16 different municipalities, made just under 4 miles of road improvements, and completed just under $2 million in road projects. I'll just show you a couple brief examples of some slide projects specifically that we've worked on, since that's our topic for today. Our first slide project was in South Fayette Township on Coal Pit Run Road. This entire project encompassed drainage work along the roadway to capture the storm water that initially caused the slide failure. And then using a GRS wall, we stepped back the hillside and recreated the roadway on top of the wall. Like Scott said, this is a very durable and strong solution for repairing slides, and this roadway is still doing very well. And you can see at the bottom of the slide in this picture, we have Coal Pit Run, and this project we awarded for $180,000. Here's a picture of the slide that we originally were going to address in Lincoln Borough. But as Kevin said, we ended up reorganizing our funding to capture the stormwater that caused the initial slide impact and utilize other funding sources to address resituating the roadway and stabilizing the slide itself. The district provided $69,000 for this grant, and that included the stepped manhole system, the installation of the catch basins. And then last but not least, we worked on Pink House Road in Swickley Heights Borough. We awarded them $158,176 to do a total excavation of this slide area and reconstruct the slide impacted area with a GRS wall. So there are a lot of applications for the dirt, gravel, and low volume road funding. Here's a list of our upcoming projects and municipalities we'll be working with. I'm happy to talk to anyone who's interested about ways that we can give you funding for your low volume or dirt and gravel project. So don't be shy to reach out and see what we can do to get your slide or your dirt, gravel, and low volume road repaired. Thanks so much, everyone, for coming today. And it looks like we have one question. Are you aware of whether the McArdle roadway slides have been addressed sufficiently? It seems a perpetual Pittsburgh challenge. Definitely a perpetual Pittsburgh challenge. I'm unfamiliar with what they're using specifically to repair those slides, but I know this is a topic that comes up almost every year, at least since I've lived here for the last 4 years. Are there any other questions from the group? All right, we went a little over time, so thank you all for bearing with us, and thank you for coming, and thanks to our speakers and PACD. I will be sending out a follow-up email to all of our participants with some additional resources for Tensar, for landslide information, and for funding sources that were discussed today. Thank you very much and hope you all have a great day.
Thank you.
Thank you.